Scientists say they've made a huge breakthrough which supports the theory that the universe started with a big bang. A telescope in the South Pole has been studying a tiny area of sky. For the first time, researchers have been able to see these waves of light, which they say must have been left behind by a rapid expansion of space a fraction of a second after the so-called Big Bang. Well, with me now to help us decipher all of this is space expert Mark Thompson. So, Mark, just how significant is this discovery? How excited are you by this tonight?
One of the amazing things about this is that we've seen evidence for the fact that the universe started as a Big Bang, and we've had theories that explain some of the conundrums in cosmology. For example, wherever we look in space, the universe seems to be the same. And there's a number of reasons why we think that should be the case, but there's this period of time called the inflationary period, which we've had as a theory, but we've never actually seen evidence for.
So this is evidence which supports the theory, and in a nutshell, can you explain to me what they've discovered?
Absolutely.
For my brain.
So what we've discovered is the effect of gravitational waves. So
wow.
The universe started as a Big Bang, the universe expanded in size.
And we're looking at it now.
We're looking at the cosmic background radiation. Those lines you can see are actually the polarization of photons of light,
wow.
woo, which basically means they're orientated in a certain direction.
And this one here?
And that's the same thing, but a slightly different frequency. So what we're looking at is the effects of gravitational waves, which is really one of the fundamental questions we've been trying to answer for quite some time, and this actually looks like we've got some way towards that now.
And we're looking actually just over here at the massive telescope in the South Pole, I believe.
Yeah, it's at the South Pole.
Huge piece of equipment.
It's cold there, which means the atmosphere is quite stable, and it's actually looking at microwave radiation as well, not visible light, and that's one of the reasons it was there.
Right, OK, so that picked it up. And we also understand that good old Einstein predicted this nearly 100 years ago. He was a bright boy, wasn't he?
He was. He knew his stuff. He proposed that gravitational waves existed 100 years ago in his general theory of relativity, and this is the first real, tangible evidence that he was actually right.
So what does it mean? What does it back up, what you and many other, including Einstein, think?
Oh, me including Einstein.
Yes,
how
well, I'm sure you think
what it does is it gives us the first chance to actually understand what may have happened to cause the universe to expand in such a fast way. Now, the universe expanded in a very small fraction of time, 100 trillion times, which is a phenomenal expansion in the fraction of a second. Okay. It helps us understand that.
So what is the next big discovery, putting you on the spot now? After this, what's next?
Oh, my word. The next big discovery, good Lord. I would imagine it probably would be more detail around what actually has been the driving force of the inflationary period of time.